Let's move on to learn about sewing machines, needles, stitches and seams. Machine bed is the part of the sewing machine on which the fabric rests while it is being sewn. The types of beds in the machine are flat, cylinder, feeder the arm, post bed, raised bed and side bed. Let us begin with the flat bed, found on lock stitch and certain chain stitch machines. Here the bed of the machine is mounted on the table of the machine, which is suitable for surface for flat sewing. A cloth plate is mounted horizontally on the bed, the part of the machine on which the fabric rests while being sewn. This is the work surface. The material can easily be guided around the needle and the pressure foot. The flat bed is used in most sewing techniques, where a large and open garment part can easily be handled past the needle. It provides a suitable surface for much flat sewing and also facilitates the use of markers to control the position of the garment parts. The machine allows manipulation of fabric on both sides of the needle for top stitching and lap seaming. For example, a patch pocket on a shirt front. Here, the cloth plate is located horizontally at the upper end of a horizontal cylinder. Cylinder or open arm beds are used to sew tubular items such as sleeve circumferences or tubular neck bands. The fabric is turned around the arm while seaming. It permits one to sew a cylindrically shaped item. This shape allows easy rotation of the item that is to be stitched. the feed of the arm. This is also a type of cylinder bed machine. The bed of the machine is U-shaped. These machines are used where a lapped seam has to be closed in such a way that the garment part becomes a tube. The stitching is along the length of the cylinder. It is common in jeans production for inseam. Post bed machines have the cloth plate attached horizontally to the top of a narrow post or small platform above the table surface. These types of machines are commonly used for footwear, where the parts to be sewn are small, curved or awkward in shape. The sewing area is very small and therefore permits the item to be turned without difficulty. For example, bars and shoes. raised bed. Here the bed plate is in the form of a plinth. It facilitates the assembly of pre-sewn parts and is especially suitable for the fitting of accessories and special attachments. This is the basic form for various specialized machines such as buttonhole machine. Side bed. It trims the edge of the fabric in front of the needle just as it is sewn. Machines which are specialized for sewing at edges need only a small working area. Example are overlock machine. Now on to the principal role of the feed mechanism. The feed mechanism is essentially a transportation device for repeatedly moving the material being stitched from one stitch position to the next at regular intervals. The feed system is made up of the following components, which are often referred to as the fittings because they fit together as a component set. Feed dog, pressure foot. The feed dog has raised lines of hardened steel, each with multiple rows of steel teeth that grip and move the material during stitching. The pressure foot is a solid or hinged flat surface that holds the material against the needle plate or lower feed during sewing. It provides stability around the needle point, which helps the correct loop formation of the stitch beneath the fabric. The needle plate is designed to support the material being sewn and ensure it passes smoothly through the machine. It has a needle hole to allow the needle and the thread to penetrate the fabric, and there are slots for the feed dog to rise through and meet the underside of the fabric. Several different feed systems have been developed for the modern sewing machine. Selecting the right feed system ensures that stitch formation and length remain consistent, resulting in the highest possible seam quality. There are several feed types. They are drop feed, compound feed, differential drop feed, unison feed, drop feed and variable top feed, differential top and variable top feed, wheel feed, puller feed. Drop feed. This 4-motion feed system is probably the most widely used feed type in the clothing industry today. Description. The lower feed dog works with the pressure of the sewing machine foot to feed the material over the needle plate and through the machine. Applications. This type of feed is found in all general sewing operations. However, the operator must be highly skilled in order to maintain stitch quality at acceptable working speeds. Compound feed. Description. Compound feed is a 4-motion feed system in which the drop feed and the needle move forward in unison in the material during the feeding movement. Applications are: this type of feed reduces seam pucker on light slippery fabrics and will reduce needle breakage on thick materials, especially on multiple thickness such as cross seams. It is also ideal for stitching denim, protective clothing and in top stitching applications. Differential feed. Almost every overlock and chain stitch machine uses this 4-motion tandem feed system. Description of it: the feed system uses two separate lower feed mechanisms that move together in tandem. The adjustments can be done in this feed system by using different stitch regulators to control the timing of each of the lower feed mechanisms. Altering one regulator moves the feed dog at a different rate, and this is often used for stretching or gathering the material being sewn. Applications are overlock and chain stitch machines are found extensively throughout the knitwear industry. The lingerie industry relies on lock stitch machines for operations such as attaching lace to slips and nightwear, and lock stitch zigzag machines for making bras using this feed type. Unison feed. This feed system has a lifting foot with a feeding foot connected to the needle drive, and the feed dog and these move together in the material as a walking foot. Description: the feed dog, feeding foot and the needle bar all move together along the line of stitching. The lifting foot then contacts the material, holding it firmly, while the needle and the feeding foot rise and with the feed dog returns to the start of the next stitch. The applications of this feed system is useful for stitching rigid materials such as upholstery, leather and plastic, which often have extra heavy cross seams. Draft feed and variable top feed. This 4-motion draft feed has an adjustable top feed system. Description: these are two separate feed mechanisms, one above the pressure foot and one below, each moving at the same or different rate of speed to produce a completely flat seam. With adjustments, this feed system can be used for stretching or gathering material and is used on difficult fabrics where seam pucker is apparent. The applications are: it is particularly well suited for joining two plies of fabric as they finish evenly, especially on difficult, hard to handle materials. It is used for collars, cuffs and hems on shirts and blouses, joining side seams on knitwear, hemming linings and sleeve setting on lightweight jackets. Differential draft feed and variable top feed. This 4-motion tandem feed has an adjustable top feed system that is used by almost every top feed overlock machine. Description: it features 3 separate feed mechanisms, one above the pressure foot and 2 below, each moving at the same or different rate of speed to produce a flat seam. The feed can be adjusted to stretch or gather the material. The applications of this feed system is used to ensure an even finish when joining 3 plies of fabric and is used for piping operations on sportswear, tracksuits, pyjamas, lightweight jackets, cushions and upholstery. Wheel feed. This feed design replaces the feed dog and pressure foot with 2 wheels that contact and move the material. Description: rotating cylinders, either upper, lower or both, drive the feed. These are usually in constant contact with the material during sewing. Applications: wheel feed systems are found extensively in the boot and shoes industries, where they are used for joining and top stitching operations. They are also used in the clothing industry for sleeve setting in ladies and gents outerwear. Puller feed. This is an additional feed mechanism used to assist the regular feed in carrying the stitched material away from the needle. Description: a puller feed takes the form of a continuously or intermittently turning roller wheel positioned at the rear of the needle. Both lock stitch and chain stitch variations are used on difficult fabric where seam pucker is apparent. Applications: puller feed is particularly well suited for ensuring an even finish when joining 2 plies of fabric, especially on difficult and hard to handle materials. It is ideal for long seam operations, trouser legs, sleeve and back seams on jackets and hemming applications where quality is paramount. Puckering is a corrugated sewing line whose finished sewn length is equal to or more its original cut length. It is often confused with gathering. Puckering is caused by the stitching action, feed action or both. It is actually the result of a ratio resulting from the integration of the following dimensions and characteristics: yarn count, yarn diameter, yarn tension, thread diameter, thread elasticity, stitch size, stitch tension, needle diameter, needle contact velocity, feed tooth dimension and feed velocity. 4 probable causes of seam pucker are: feed pucker, tension pucker, displacement pucker of jamming and moisture pucker. Feed pucker is due to the resistance or drag of the pressure foot on the top ply as the 2 plies of fabric are sewn together. If the fabric on the bottom is fed more rapidly than the top ply, the bottom fabric puckers. Using a top feeding device may be one resolution to the problem. A top feeding mechanism that moves the top fly of the fabric through the stitching process at approximately the same rate as the bottom feed eliminates much of the resistance on the top ply. Differential stretching of the two plies being sewn may also cause only one side of the seam to pucker. This might occur when braid or trim is sewn to a blouse or jacket. If one piece has a greater degree of bias, it will be more susceptible to stretch. Tension pucker may be caused by too much tension on the sewing thread, which causes the thread to elongate as stitches are formed. Tight tension settings on upper or lower threads during stitching or bobbin winding or damaged thread guides may be other causes. Tension pucker is primarily a problem with synthetic thread, which has greater elongation capabilities than other thread. As the thread relaxes, it can cause the fabric to draw together and pucker. Thread that is poor quality or the wrong size or type and incorrect settings are other probable causes of tension pucker. Tension pucker may be eliminated with properly adjusted machines and use of consistent quality thread. Fine threads and well lubricated threads can be sewn with light tension due to its looped formation. Displacement pucker or jamming is due to yarn displacement and crowding as the needle and thread pass through the fabric. Yarns are pushed together as threads form stitches in the fabric. Displacement pucker is most common on high count fabrics with long seams cut parallel to warp yarns. The tendency of jamming increases with more stitches per inch, higher count fabrics, finer fabrics and thicker sewing threads. Possible solutions for jamming are the use of a 2-thread chain stitch instead of a lock stitch machine. Other solutions include use of finer sewing threads and a smaller needle, fewer stitches per inch and cutting adjoining garment pieces with a slight degree of bias, so there is more room for yarn displacement. Moisture pucker is not the result of a sewing process, but is of concern to the lasting appearance of a garment. Moisture pucker is due to differential shrinkage of the shell fabric, thread or other attached materials such as trims and interlinings. Differential shrinkage of components may be avoided by early product testing during the development stage to ensure all materials are compatible during sewing and care. Seam grin is a separation of a sewn seam as a result of transverse stress that allows the stitches and thread to show. It is a condition that is likely to occur with a low stitch count, insufficient tension on threads or improper stitch and seam selection. It affects both the aesthetics and performance. The final module focuses on cyclical sewing machines. Cyclical sewing machines are automatic machines which can perform a short automatic cycle like a button sew, buttonhole, Bartek and label sew. In olden days, the cyclical sewing machines were of limited configuration, but whereas current cyclical sewing machines have microprocessor controls which allow for a greater variety of stitching configuration. Buttonhole machines operations depend upon the characteristics of the buttonhole to be sewn. The variables are stitch density, stitch bite, stitch type, lock stitch or single or 2-thread chain stitch, form and size, whether buttonhole is cut before or after sewing, presence or absence of a gimp. Generally, buttonhole machines have a clamp feed, with the clamp being able to move in a horizontal plane. In a microprocessor controlled buttonhole machine, a console is provided on the side. The operator can use this to choose the pattern, stitch density and buttonhole size. A buttonhole can be a welt buttonhole, loop buttonhole, straight buttonhole and a keyhole buttonhole. Weld buttonhole. This looks like a welt pocket. It is normally used in leather apparels. Loop buttonhole. In a loop buttonhole, a loop is formed using either thread or fabric to allow the button to fasten. It is considered as a style element in ladies' garments. Straight buttonhole. In straight buttonhole, a slit with cut edges encased in thread and ends with wide stitching or Bartek. Keyhole buttonhole. A keyhole buttonhole has an enlarged round shape at the end closest to the garment opening. This one is normally seen in jackets and coats and jeans. When a raised pearl effect is required in keyhole, an extra stiff thread called gimp is laid at the very end of the buttonhole to reinforce it before the buttonhole is stitched. Cut and sew buttonholes are generally used for heavyweight fabrics where the fabric does not flag too much. These are called as cut before buttonholes also. These give a neat appearance as the cut is covered by threads, but once a cut is made, the buttonhole position cannot be changed. Sew and cut buttonholes or cut after buttonholes offer more stability while stitching, but the cut edges can be frayed. Further, if the lining and body fabric are present in the same part with different colors, then the cut exposes both colors. But the fraying of cut edge gives a faded, worn look which is desirable in jeans. Lock stitch buttonholes are secure, but chain stitch buttonholes give an attractive pearl effect to the buttonholes. This is a buttonhole sewing machine. அவ்வளோதான். The operation of button sew machines depend on size, shape of the button, the clamp design is influenced by this, the number and disposition of the holes, the form of stitching where there are 4 holes either crossover or parallel, which is also known as Swiss kiss, number of stitches, type of stitch used where the button has a shank or a neck. When the button is flat, while sewing the button, a spacing finger is used to create space for the thread shank. In shank buttons, the button is clamped on its side during sewing and the needle passes alternately into the garment and into the hole in the shank and into the garment. Button sewing with lock stitch is secure, but it leaves an untidy look on the stitching on the other side of the fabric from button, whereas chain stitch button sewing gives a cleaner appearance at the back but is less secure. A hand sew appearance can be obtained by using stitch type 209. Use of button hoppers which automatically sort and line the button at the clamp, reducing the positioning work of operator, can be used for long runs of same button type and size. This is a button sew machine based on lock stitch type. You can see a clamp here which can be adjusted by loosening the screw and pressing this lever for the diameter of the button that is to be sewn. Now we have a 4-hole button here which I am going to insert and set the clamp width. Now you see that the clamp is holding the button firmly. Now I am tightening the screw to fix the clamp width. Cut. Now we are going to see how to sew different sewing patterns with the button sew machines with a 4-hole button machine. Let's try one pattern. Now we will see one more button sew pattern type. இதை வந்து நம்ம இது பண்ணி எடுத்து காமிக்கணும். Now we are going to try one more design type of button sew. Cut பண்ணிங்க. Now we have sewn this button. Now we are going to try sewing one more different sewing pattern of button sew. Cut பண்ணிங்க. Now we are going to try one more type of button sew pattern. This is the type of button we have sewn now. Barteks are used for reinforcing the ends of pocket openings and the bottom of flies and sewing on belt loops where more stress is given while usage of the garment. They are also used for reinforcing any stress points of bags. Bartek machines sew a number of stitches across a distance set, then start stitching covering stitches over and at right angles to the first stitches. Essentially, a tight zigzag stitching which repeats itself back and forth over itself. This machine is known as a Bartek machine. Basically, this machine produces zigzag stitches on a concentrated manner, something like this. The idea behind that is it gives reinforcement by giving lots of stitches within a short length of fabric. Since the stitch type produced here is of lock stitch, stitch class 300, you can find the needle and bobbin mechanism for in your view. This is the microprocessor controlled panel board for the Bartek sewing machine. The operator will use this board whenever he wants to change the characteristics of the Bartek which is being sewn. Currently, if you look at the display, it displays the number 8. It is the number here for against which the green light is shining. This means the 8 number design is currently loaded. Now, if I want to change the design type, what I have to do is that I have to press this. Now, I can sew the 11th design type Bartek, or if I want to, I can go for 12th, I can go for 13th. Each machinery manufacturer gives somewhat around 20 to 100 different designs inbuilt. Now, if I want to increase the or decrease the length, that is being given here as x-axis. Now, to arrive at it, I have to use this purple dongle key. I have come here. Now, currently it is at 100. That means the fullest extent possible, the length is there. So, if I want to reduce it, I can reduce it to whatever value I want. Same way, if I want to increase or decrease the width, I have to change a y-axis value. Here again, I have to go to y-axis using the purple key. Already it is in 100, so I am going to reduce it. So, I am reducing it to 95. Once this is been set, the operator presses the green button to load this configuration into the machine now. Now, whatever Bartek is being sewn will be of stitch number chosen and the x and y values chosen. Now, we are going to sew the number 1 design type in this machine with 100% in x and y axis. Cut பண்ணிங்க rolling. Now, we are going to sew the same design number 1, but with x and y axis reduced to 50% and 50%. Let us see the output. Now, you can see the reduced output of 50 and 50 for the same design type. Now, we are going to try design number 2 at 100 and 100 in x and y axis. Cut பண்ணிருங்க. Now, we are going to try design number 3 here. Now, we are going to try design number 5 here. Now we are going to try design number 6 here. You can see the difference in design. Now we are going to try design number 7 here. Now we are going to try design number 8 here. Now we are going to try design number 11 here. Now we are going to try design number 12 here. Now we are going to try design number 13 here. Now we are going to try design number 14 here. Now we are going to try design number 15 here. Now we are going to try design number 16 here. Now we are going to try design number 17 here. Now we are going to try design number 18 here. Now we are going to try design number 38. Now we are going to try design number 51. Now you see all the different types of patterns which are shown by this Bartek machine in the same specimen. Using microprocessor,
okay.
control panel, it is possible to set the width of the Bartek, the pattern and the stitch density. Also, it is possible to do a limited number of patterns by using a EEPROM, electronically programmable random memory. This is a electronically controlled keyhole stitching machine. This is one more view of the keyhole stitching machine. Now you are looking at the thread holders. This one is the needle thread. The red one is the gimp thread. This is the microprocessor controlled control panel. This displays the stitch design. This displays the length of the stitches. These buttons are used for changing. This is the cut after buttonhole button. This is cut before buttonhole button. This is knife on and off. All these buttons will control the characteristic related to the buttonhole. Now we are going to show the keyhole. Left side there are two fingers. One finger activates the clamp. The other finger activates the sewing action. Now the keyhole is being sewn. Automatically the knife comes down, makes the hole. You can see the back of the keyhole. A simple label sewer will perform zigzag stitches to a predetermined length on one or two edges of a label. Advanced machines are programmable profile stitches that can sew a wide variety of shapes and sizes of label. When a label has to be sewn over the inside pocket of a jacket, a special label sewer with cylinder bed is used. You have come to the end of this unit. To summarize, in this unit, you have been given an overview of single needle lock stitch machine and cyclical sewing machines. Thank you.